Hi everyone, and welcome to the last lesson of physics for the year. You heard that right. More about that coming up in a little bit. But for our last lesson of the year, we're taking a look at the Fermi paradox with a video from KARDASHEV. So check this out, grab your pen and pencil, whatever you take notes on, that way you can answer the questions in a minute. Best of luck, and I hope this sparks your imagination.
Are we the only living things in the entire universe? The observable universe is about 90 billion light-years in diameter. There are at least 100 billion galaxies, each with 100 to 1,000 billion stars. Recently, we've learned that planets are very common too. And there are probably trillions and trillions of habitable planets in the universe, which means there should be lots of opportunity for life to develop and exist, right? But where is it? Shouldn't the universe be teeming with spaceships? Let's take a step back. Even if there are alien civilizations in other galaxies, there's no way we'll ever know about them. Basically, everything outside of our direct galactic neighborhood, the so-called local group, is pretty much out of our reach forever because of the expansion of the universe. Even if we had really fast spaceships, it would literally take billions of years to reach these places, traveling through the emptiest areas in the universe. So let's focus on the Milky Way. The Milky Way is our home galaxy. It consists of up to 400 billion stars. That's a lot of stars, roughly 10,000 for every grain of sand on Earth. There are about 20 billion Sun-like stars in the Milky Way, and estimates suggest that a fifth of them have an Earth-sized planet in its habitable zone, the area with conditions that enable life to exist. If only 0.1% of those planets harbored life, there would be 1 million planets with life in the Milky Way. But wait, there's more. The Milky Way is about 13 billion years old. In the beginning, it would not have been a good place for life because things exploded a lot. But after 1 to 2 billion years, the first habitable planets were born. Earth is only 4 billion years old, so there have probably been trillions of chances for life to develop on other planets in the past. If only a single one of them had developed into a space-traveling super-civilization, we would have noticed by now. What would such a civilization look like? There are 3 categories. A Type 1 civilization would be able to access the whole energy available on its planet. In case you're wondering, we're currently around 0.73 on the scale, and we should reach Type 1 sometime in the next couple of hundred years. Type 2 would be a civilization capable of harnessing all of the energy of its home star. This would require some serious science fiction, but it is doable in principle. Concepts like the Dyson sphere, a giant complex surrounding the Sun, would be conceivable. Type 3 is a civilization that basically controls its whole galaxy and its energy. An alien race this advanced would probably be godlike to us. But why should we be able to see such an alien civilization in the first place? If we were to build generation spaceships that could sustain a population for around 1,000 years, we could colonize the whole galaxy in 2 million years. Sounds like a long time, but remember, the Milky Way is huge. So if it takes a couple of million years to colonize the entire galaxy, and there are possibly millions, if not billions of planets that sustain life in the Milky Way, and these other life forms have had considerably more time than we've had, then where are all the aliens? This is the Fermi paradox, and nobody has an answer to it.